Okay, this problem's really cool because it deals with everyday life when, you know, being in a car and airbags, seat belts. It pretty much is the reason why you need to wear a seatbelt. So the problem goes, it says a car moving at 20 meters per second crashes into a tree. Find the magnitude of the average force acting on a passenger of a mass of 65 kilograms in each of the following cases. A. The passenger is not wearing a seatbelt. He is brought to rest by the collision with the windshield and the dashboard that lasts 3 milliseconds. In B, the car is equipped with a passenger side airbag. The force due to the airbag acts for 30 milliseconds, bringing the passenger to rest. So, this is a really interesting problem, and let's get started. So, to start, we have the impulse momentum theory. Is the change in P is equal to the change in F average times the change in time. So this is where, like I have it set up right here, that the F average is the average force acting on the passenger, and the change in T is the time interval. So the change in the passenger's momentum is going to be the same in both cases, but the thing that's different is the time interval, which is when the time occurs. It takes a larger force to change momentum in a shorter time interval. So the passengers and P sub I is equal to mv sub I, and I plug my values in for that. So I get that it is 1,300 kilograms meters per second. So the final momentum is going to be 0. So that the change in P is going to be equal to 1,300 kilograms meters per second. So this momentum of change divided by the time interval, it gives us the average. Gives us the average case here. So the case in part A with no seatbelt, the F average is equal to change in P divided by change in time. After plugging in the values for that, I get 4.3 times 10 to the 5th newtons. And then in case B with the airbag, the F average is equal to the change P divided by the change in time. And I plug my values in for this, and I get 4.3 times 10 to the 4th newtons. And this problem's so interesting because just it really shows you the safety issues with cars and not wearing seat belts. I mean, you can see the force of the airbag with the no seat belt was definitely greater than the one with the airbag. So I mean, either way, if you have an airbag or if you don't, you need to buckle up. And this is cool how physics is used to actually help bring awareness of things, and we can prevent injuries by having physics and showing how seatbelts are good.